7G. Rewrite radical expressions that contain variables to equivalent forms. Simplify. Use absolute value signs when necessary. When it says to use absolute value signs when necessary, this is what it's referring to. So, if n is an even positive integer, like all the questions on this page, it has a 2, then you would have the absolute value of the variable to the reduced form. Now, if you had an odd positive integer, if there's like a 3 right here, you wouldn't have to use absolute value signs. It's only for even indexes. Most examples say the directions to assume the variables are positive real numbers. However, if a problem does not indicate that, then you need to assume that we are dealing with both positive and negative real numbers and use this rule. So let's look at some of these. For number 36, we have the square root of 24. We are pulling out perfect squares. You want to try to pull out these numbers right here. The square root of negative 1, the square root of 4, the square root of 9, the square root of 25, and the square root of 49. The square root of negative 1 is I, the square root of 4 is 2, the square root of 9 is 3, the square root of 25 is 5, and the square root of 49 is 7. About 90% of all the problems you'll ever see will have either one or more of these numbers to pull out if it could be reduced. So for 24, we know that 24 is 4 times 6. So we could pull out a perfect square. The square root of 4 is 2. So we have 2 square root 6. The 6 is left over inside because we cannot pull out any of these perfect squares evenly. Let's look at 38. We have negative 3 times the square root of 108. So we have negative 3 times 108 is 9 times 12. 12, you can also take out a perfect square of 4. So we have negative 3 times the square root of 9 times the square root of 4 times the square root of 3. 4 times 3 is 12. 12 times 9 is 108. So we have negative 3 times 3 times 2 times the square root of 3. And if you multiply those together, you get negative 18 times the square root of 3. That's your reduced radical. On number 40, we have a variable here. So we're going to separate this into two different problems. We have a square root of 192, and we have the square root of p to the 4th power. Now, the square root of 192, we'll do it the same way that we did the previous two problems. See if we can pull out any of these perfect squares. You can use a calculator if you need to for these as well. So let's go ahead and look at that. So 192 divided by 4. Okay, that works. It's 48. How about 192 divided by 9? That doesn't work because there's a decimal there. How about 192 divided by 25? Decimal, so we're going to skip that and try the last one. 192 divided by 49. Okay, so it looks like we can only pull out 4. So 192 is the same thing as 48 times 4. Well, 48 we could pull out another 4. So it'd be 12 times 4 times 4. For 12 you could pull out another 4. So we have 3 times 4 times 4 times 4. Well, if we take the square root of each of those, 4, 4, and 4, we have 2 times 2 times 2. That's 8. 8 square root 3. So that's for the number part. Now for the variable, we have p to the 4th power. We'll rewrite this as an exponent, p to the 4 over 2. We write a 2 in the denominator because a square root has an index of 2. The index will always go in the denominator of your exponent. 4 divided by 2 is 2 with no remainder. So we can rewrite this as p squared. We don't have to put absolute value signs around it because anything squared that's a real number would still be positive. So our simplified form would be 8 times p squared times the square root of 3. Let's look at 42. 2 times the square root of 180 times k to the 4th power. So for this one, we're going to split it up just like on 40. So we have 2 square root of 180, and then we have the square root of k to the 4th power. Okay, well 180 is 9 times 20. And for 20, we could take out a 4. 4 times 5 is 20. So 9 times 4 times 5. Okay, so we have 2 times the square root of 9 times the square root of 4 times the square root of 5. That's going to be 2 times 3 times 2 times the square root of 5. If you multiply these three numbers together, we get 12 square root 5. Okay, now we're going to find the square root of k to the 4th power. K to the 4th power is the same thing as k to the 4 over 2, which is k squared. Again, we don't have to put absolute value signs because this is an even degree. So our simplified radical would be 12 k squared square root 5. Let's look at number 44. We're simplifying this expression. 3 square root 27 minus 4 square root 27 plus 4 square root 96. Well, we already have like terms here, so we can go ahead and combine those first. So then we just have negative 1 square root of 27 plus 4 square root of 96. We're not done though. We need to see if we can simplify these square roots. Okay, let's simplify the square root of 27. The square root of 27, we can factor out a perfect square of 9. 9 times 3 is 27. So then we have the square root of 9 times the square root of 3. And then we have negative 1 in the front. So we have negative 3 square root 3. So this would reduce to negative 3 square root 3. Now we'll try to reduce the square root of 96. And let's see what we can take out of that. Okay, so there's no negative there, so we can't take out negative 1. Let's try 4. Okay, that's 24. The square root of 96 is the same thing as 4 times 24. 24 is the same thing as 4 times 6. So we have the square root of 4 times the square root of 4 times the square root of 6. 2 times 2 times the square root of 6, 4 square root 6. And then we have 4 on the outside from the beginning. So we're going to multiply this by 4 to get 16 square root 6. So our simplified expression is negative 3 square root 3 plus 16 square root 6. Can't reduce it any more than that, so that would be your answer. Let's look at 46. We have 6 square root of 21a squared times negative 3 square root of 14a cubed. So what you want to do is multiply the numbers together. We'll do this in blue. So we have 6 times negative 3, and then we have times the square root of 21 times 14 times a squared times a cubed. From your law of exponents from Algebra 1, we know that a squared times a cubed is a to the 2 plus 3 power. And then 21 times 14, 294. And then negative 3 times 6 is negative 18. So we're not done there. We want to simplify this radical. So we have negative 18 square root of 294, which looks like it would have 7s in it. And then we have square root of a to the 5th. It's 5 because 2 plus 3 is 5. Okay, so 294. Let's see if what goes into this. Let's try, there's no negative, so we can skip negative 1. Let's try 4. Okay, that's a decimal. That doesn't work. We'll move to the next one. 9. That also doesn't work. It has a decimal. 294 divided by 25. Nope, it's a decimal, so we're going to move on to 49. It's 6. So we have negative 18 times the square root of 49 times the square root of 6. The square root of 49 is 7. So we have negative 18 times 7 times the square root of 6. So that'd be negative 126 times the square root of 6. So that's your number part. Now let's look at the variable. A to the 5th power is the same thing as a to the 5, or the square root of a to the 5th power is the same thing as a to the 5 over 2. Well, we're going to have a remainder here, so let's go back to our elementary math and divide this. 2 goes to the 5 2 times. 2 times 2 is 4. 5 minus 4 is 1. You have a remainder of 1. That means that you have a to the quotient on the outside, which is 2, and then on the inside of the square root, you'll have a to the remainder, which is 1. No decimals here. We're finding remainders so we know which exponent to put on the inside. Again, this is squared, so we don't have to put absolute value signs. So let's put it all together. We have negative 126 a squared times the square root of 6a. I'll write that right here too. Negative 126 a squared times the square root of 6a. Okay, let's do one more on this page. 48. Negative 5 all over negative 2 minus square root 5. We want to rationalize this denominator because we don't want imaginary numbers or radicals or anything weird in the denominator. We just want natural numbers. So we're going to multiply by the conjugate, which is just to get a difference of squares. You change the sign of the radical part. So it'd be negative 2 plus the square root of 5. Negative 2 square root of 5. Whenever we multiply by the denominator, we have to multiply by the numerator because we're multiplying by the unity fraction 1. So if we multiply these out, we could do FOIL. -2 times -2 is 4. -2 times square root 5 is -2 square root 5. Negative square root 5 times -2 is positive 2 square root 5. And then negative square root 5 times positive square root 5 is a -5. Because you would have a 25 inside, the square root of 25 is just 5. These cancel. And then you would also multiply these. So we have -10 minus 5 square root 5 all over 4 minus 5. If we reduce this negative could go into both of these. 10 plus 5 square root 5 all over -1. We could divide each term by -1, and then you get -10 minus 5 square root 5. Or this would be a positive 5. So you have -10 plus 5 square root 5. So to rationalize the denominator, you just change the sign of the square root part. Multiply those and you get a difference of 2 squares. Simplify. Reduce the fractions needed. Okay, try the other half of this page by yourself or with a partner. Be sure to check the key to see if you're doing it right.